Hello, welcome to the Argo course. My name is Mohammed and I'm very happy to be here. In the previous session, we talked about blue-green deployment strategy in Argo rollouts. And we found out a lot of things about it. But in this session, I'm going to talk about Canary deployment strategy in Argo rollouts. Okay. As you can see in this picture, a Canary deployment exposes a subset of users to the new version of the application while serving the rest of the traffic to the old version. Once the new version is verified to be correct, the new version can gradually replace the old version. Very good. Therefore, we have a strategy called Canary. And there are multiple ways to use this strategy. The first way to use Canary strategy is rolling update. This option, rolling update, is available in Kubernetes deployment object 2. So we have two important options in rolling update. The first one is max search, and the second one is max unavailable. Max search. This parameter specifies the maximum number of pods that can be created above the desired number of replicas during the rolling update process. And max unavailable, this parameter specifies the maximum number of pods that can be unavailable during the rolling update process. Let's say you have a deployment with 5 replicas running your application. You want to update to a new version, but you don't want to take all replicas down at once. You can set the max unavailable parameter to 2. Max unavailable 2. Which means Kubernetes will ensure that at least 3 pods are available at all times during the update process. You also want to make sure that the update process doesn't create too many pods at once. You can set the max search parameter to 1. Max search. Which means Kubernetes will only create 1 new pod above the desired number of replicas, in this case 5, during the update process. So, during the update process, there will be a maximum number of 6 pods running your application at any given time. Okay, it was about max surge and max unavailable. I'm going to explain both of them in the rest of this session. The second way to use Canary strategy is using SetWeight in Argo rollouts. The SetWeight field indicates the percentage of traffic that should be sent to the Canary. SetWeight and also rolling update must be defined under Canary strategy block and Argo rollouts definition. So SetWeight is a field under Canary strategy as well as a rolling update. Okay. So we can define the percentage of traffic that should be sent to the canary using SetWeight. And the last option and the last way to use Canary Strategy is traffic management or traffic routing. We can use an ingress controller, for example, to manage the traffic and to route the traffic. In this session, I'm going to use nginx-ingress-controller to show you how it works. Nginx can help us to manage the traffic of the Canary deployment. So, these are the ways to use Canary Strategy, and I'm going to explain all of them in this session. In this section, I'm going to use a rolling update. Therefore, we have a new directory called Argo-rollouts Canary, and we have multiple files here, and one of them is rolling update. Let's click on it. The kind is rollout, and the name of the rollout is rolling update. The number of replicas is 5. And in this time, I'm using Canary Strategy instead of Blue-green. As I said earlier, we are using rolling update in this example. Therefore, these are two important options of rolling update, max surge and max unavailable. Both of them are true. The label is rolling update. The name of the container is rolling update 2. And the name of the image is Canary. This is the same image that we used in the previous session, blue-green deployment session. And I just retagged it to Canary. If I type Docker images grep-e Canary and blue-green, these are two images with the same hash ID. So both of them are the same, and I just retagged it to Canary, and I'm using this image with this name in this example. My application needs an environment variable. This application needs to render HTML file. Because of that, I need to give it an environment variable. The name of the environment variable is HTML name, and its value is app-v1.html. So, in this example, I'm using version 1 of the application. If you want to use the second version of the application, you have to replace app-v1 to app-v2. And the container port is this. And also, I'm creating a service for this rollout because the selector is app equals rolling update. And the label of this rollout is rolling update, as you can see here. So the endpoint of this service is this rollout. So in this example, I'm creating two different objects, a rollout and a service for this rollout. Very good. Another file of this example is rolling update ingress. I have created a file called rolling update ingress.yaml, and I'm using nginx-ingress-controller for this example, and the backend service of this ingress is rolling update. this service. Okay. First of all, let's create a namespace for this session called Canary. Get an S, very good. And I'm going to switch to this namespace by default. So I type kubectl config set context -- current -- namespace equals Canary. So we are in Canary namespace by default. I copy this content, very good. Let's create a directory here called rollouts and go to this directory and let's create first example1.yam, and I paste the content here. Very good. And example1 ingress. This is the ingress related to this example. Very good. We are in Canary namespace by default, so there is no need to switch to this Canary for every command. So I type kubectl apply -f example1.yam and example1-ingress.yam. We need to access to Argo-rollouts dashboard. Because of that, I type kubectl Argo-rollouts dashboard, and we can access to this dashboard using this URL. So this is the dashboard, and this is rolling update. The revision 1 and the strategy is Canary. How can we access to this Canary using the URL? If I go to example1-ingress, the host is rolling-update.demo. This domain name is available in my etc host file. So I type http and yes, this is version 1 of the application. And the domain name is rolling-update.demo. Okay. If I go to Argo-rollouts dashboard, we have 5 replicas of the application. And this is the replicas related to the first version of the application. If I type kubectl get ReplicaSet, this is the replica set of the first version of the application. And the number of replicas is 5. If I modify and if I update one of the items under template, spec.template block, Argo-rollouts controller will create a new replica set for the new version of the application. So if I type example1.yam, I can replace the value related to app-v1.html to app-v2.html. I'm modifying one item under spec.template block. So Argo-rollouts controller will create a new replica set for the new version of the application. As you can see here, the number of replicas is 5 and the max surge is 2 and max unavailable is 2. what happens if I apply this rollout again? Let's go to the note. The number of replicas is 5. The max unavailable is 2 and max surge is 2. And this example. The maximum number of pods during the rolling update process will be 7 pods. 5 replicas plus 2 additional pods because of max surge. 5 plus 2. So the maximum number of pods during update process will be 7. And the minimum number of pods during update process will be 3 pods. Five replicas minus 2 on available pods because of max unavailable. It means that 2 pods will be terminated from the old replica set. Okay, so we will have 7 pods during update process. 5 minus 2 because of max unavailable is 2. 5 is replicas and 2 is max unavailable. 5 minus 2 is 3. And 5 plus 2 is 7. 2 is for max surge. 5 is replicas and 2 is for surge. And 7. We will have 7 pods. 3 of these pods is belong to the old replica set. 3 of these 7 pods belong to old replica set. And the rest of the pods belong to new replica set. 4 of 7 is related to new replica set and new version of the application. At the beginning of the update process, 3 of these 7 pods related to old replica set and 4 of 7 pods related to new replica set. Let's how this works. If I save this manifest, I replace app-v1 to app-v2. Let's save this file and let's apply it again. But before that, I type kubectl get ReplicaSet. This is the replica set related to the first version of the application, and the number of pods is 5. If I type kubectl apply this example, this rollout, as you can see here, at the beginning of the update process, the number of pods related to the old replica set will be 3, as I said here. And the rest of the pods related to the new replica set, 4 pods, as I said here. This is the beginning of the update process. And then if I type it again, we have 5 pods of the new replica set. and the old replica set has been scaled down, and it's 0. So it was about the beginning of the update process. And one pod is terminated from old replica set, as you can see here. Okay. It was about 2 max unavailable and 2 max search. Let's go for the next example. As you can see, we are in revision 2 and the number of replicas is 5 and the revision 1 is terminating. Let's go for the next example. In the next example, I'm going to use max unavailable equals 0 and max search equals 2. What happens if I switch to the new version of the application? We will have 7 pods here. 5 replicas equals 2 additional pods related to max search. But what happens for max unavailable? Max unavailable is 0. So we have 7 pods related to the old replica set. So 5 of 7 related to old replica set. And also the rest of the pods related to the new replica set. 2 of 7 related to new replica set. So if I switch to the new version of the application, at the beginning of the update process, there will be 7 pods. 5 pods of these 7 pods related to old replica set, and 2 pods from these 7 pods related to new replica set. This is about the beginning of the update process. First of all, I delete the previous example. Okay, very good. So if I refresh this page, there is no rollout here. Okay. I go to example 1. First of all, let's change the value from _v2 to _v1, and also I'm going to replace 0 here for max unavailable. So 5 pods related to old replica set and 2 pods related to new replica set at the beginning of the update process. Let's see what happens. If I type kubectl apply -f example1.yaml. Okay. I'm waiting for this rollout here. Okay. We are in revision 1 and the number of replicas is 5. If I type kubectl get res, we are in revision 1. So if I go to definition of the rollout and if I replace this value with _v2, I type kubectl apply and get res. As you can see here, at the beginning of the update process, the number of pods related to the old replica set is 5, as I said here, 5 of 7. And the number of replicas related to the new replica set is 2, as I said here. And at the end of the update process, we are in revision 2. The number of pods is 5. So we are in revision 2 and we are in this new replica set. And the replica set related to the old version is terminating. So if I refresh this page, we are in version 2. Okay. It was about max surge and max unavailable, but okay. Let's go for the next example, for the last example of the rolling update. In this time, we have 3 replicas. I'm going to use max unavailable and max surge for this example. Max unavailable will be 1 and max surge will be, for example, 1. The maximum number of pods will be 4 pods. I copy this and paste it here. The maximum number of pods will be 4, 3 replicas plus 1 additional pods. So we will have 4 pods. Three replicas minus 1 max unavailable pods equals 2 pods. And 3 replicas plus 1 max surge replicas will be 4 pods. 2 pods, 2 of 4, belong to old replica set, and 2 of 4 belong to new replica set at the beginning of the update process. Let's do that. First of all, let's delete the rollout, the previous rollout. So I type kubectl example 1. Very good. And there is no rollout here. Very good. First of all, let's replace it with f-v1 here. I'm going to change the number of replicas from 5 to 3. Max surge will be 1 and max unavailable will be 1. kubectl apply -f example1.yaml. We are in revision 1. If I refresh this page, we are in version 1. And the number of replicas is 3. kubectl get res. Let's switch to the new version of the application. Because of that, I replace the value to f-v2. Very good. And I apply it again. And as you can see here, at the beginning of the update process, the number of pods of the old replica set is 2, and the number of pods related to the new replica set is 2. And now we have 3 pods related to the new replica set, and the old replica set has been terminated. So we are in revision 2, revision 1 is terminating. So if I refresh this page, we are in version 2. Okay, it was about rolling update, max unavailable, and max search. Another way to use Canary Strategy is using SetWeight, as I said earlier. Let's go to VS Code and open the file related to SetWeight example. The kind is rollout, and the name of the rollout is rollout SetWeight, and the number of replicas is 5. The most important thing in this rollout is steps. We have a list of steps, and each step can have one of two fields: SetWeight or pause. The SetWeight field decays the percentage of traffic that should be sent to the canary. For example, in the first step, we have SetWeight equals 20. It means that 20% of traffic should be sent to the canary. 20% of 5 pods is 1. So we have 1 pod for the new version of the application. In the next step, we have pause. The pause struct instructs the rollout to pause. In this example, pause has no duration, but we have duration for this step, and this step, and this step. If the duration field within the pause struct is set, the rollout will not progress the next step until it has waited for the value of the duration field. Otherwise, the rollout will wait indefinitely until we promote the rollout manually. In this example, we have 5 replicas. In the first step, if we switch to the new version of the application, in the first step, 20% of the traffic should be sent to the canary. So we will have 1 pod for the new version because 20% of 5 is 1. 4 pods belong to the old ReplicaSet and 1 pod belongs to the new ReplicaSet. In the next step, we have pause, but it has no duration. So in this situation, we have to promote the rollout manually. And if we promote the rollout manually, in the next step, we have SetWeight equals 40%. 40% of 5 is 2. So now, in this step, we have 2 pods of new ReplicaSet and 3 pods of old ReplicaSet. In the next step, the rollout process will be paused for 10 seconds. And after 10 seconds, 60% of traffic should be sent to the canary. 60% of 5 is 3. So we will have 3 pods of new version and 2 pods of old version. And then we have a pause with 20 seconds duration. And the rollout process will be paused for 20 seconds. And after 20 seconds, 80% of traffic should be sent to the canary. 80% of 5 is 4. So in this situation, we will have 4 pods of new version and 1 pod of old version. And after that, we have a pause here, and the rollout will be paused for 1 minute. And after that, all the traffic should be sent to the canary. And in this situation, we will have 5 pods related to the new version, and the old version has no pods, and its ReplicaSet will be terminated. It was about the steps that we have in this strategy. We also have rounding up in this strategy. What does it mean? It means that, for example, we have a rollout with 10 replicas and 10% of this rollout is 1 replicas. The controller will scale the new desired replica set to 1 replicas and the old stable replica set to 9. In the case where the set weight is 15%, the rollout attempts to get there by rounding up the calculation. The new replica set has 2 pods since 15% of 10 rounds up to 2, and the old replica set has 9 pods since 85% of 10 rounds up to 9. This is so important. Okay, let's do this example. Therefore, I copy the content and let's create a new file called example2.yaml and I paste the content here. We have 2 different objects, a rollout and a service for this rollout. The difference between this example and the previous example is the steps. We are using SetWeight&Pause instead of max search in max unavailable. I save the file. We have another file called example2-ingress. I'm using a new ingress for this example, but the difference is the backend service. The backend service is rollouts SetWeight. So we are using this ingress for this example. So I copy the content. I copy the content and paste here. Very good. The host is rollout setweight.demo. This domain name is available in my etc host, so there's no problem like that. I save the file. Very good. Okay. Let's apply these 2 different files. I type kubectl apply -f example2.yaml and example2-ingress.yaml. So if I type http and rollout setweight.demo, we are in version 1 and this. We have a list of steps here. SetWeight, pause, and any other steps. If we switch to a new version, 20% of traffic should be sent to the new version of the application. And then we have a step called pause, and it has no duration. It means that in this step, we have to promote the rollout manually. And after that, 40% of traffic should be sent to the canary. And after that, we have a pause for 10 seconds, and then 60% of traffic should be sent to the canary, and there is a pause for 20 seconds and other steps. So we are in version 1. If I refresh this page multiple times, there is nothing about version 2. Very good. So now I'm going to modify this file and replace the value related to HTML file from v1 to v2. And then apply this file. If I apply this file, as you can see here, the first step has been completed because we have 1 pod in revision 2 and 4 pods in revision 1 because 1 pod is terminating from revision 1. So now 20% of traffic should be sent to the Canary. Because of that, if I refresh this page multiple times, we have 20% of traffic for version 2. Let's do that. If I refresh this page, this is version 2, version 1, refresh, version 2, version 1. As you can see, if I refresh this page for 4 times, we are in version 1. And for 1 time, we're in version 2. So the 20% of traffic has been sent to version 2. We are in the second step, pause with no duration. So we have to promote the rollout manually. And after that, we will have 2 pods in revision 2 because 40% of traffic should be sent to the Canary. Let's do that. If I type kubectl argo-rollouts promote, what is the name of the rollout? Rollout SetWeight. And the rollout has been promoted, okay? So now we have 2 pods in revision 2, 10 seconds. Yes, we have 3 pods in revision 2 because of 60% of traffic. We will wait for 20 seconds, and after that, we will have 4 pods in revision 2 and 1 pod in revision 1. So let's refresh this page multiple times. Most of the traffic has been sent to version 2, as you can see here. Yes, 4 pods are available in revision 2, and we are waiting for 1 minute. And after that, all the traffic will be sent to revision 2. We are waiting for 1 minute. Very good. We are in revision 2 with 5 replicas, and revision 1 has been scaled down. So if I refresh this page multiple times, there is nothing about version 2. Okay, it was about set wait and pause. I talked about rounding up. Let's imagine that I want to use a rollout with, for example, 5 replicas. And I want to use 2 steps for this replica. The first step will be set wait equals 30. It means that 30% of the traffic should be sent to the Canary. And the next step will be a pause step with no duration. I want to promote the rollout manually. So 30% of 5 replica is 1.5. This number will be rounded up to 2. So we will have 2 replicas for the new version. 100% minus 30% will be 70%. So 70% of the traffic should be sent to stable version. And 70% of 5 replicas is 3.5. Round up to 4 pods. So we will have 2 pods for new version and 4 pods for old version. $1.5 round up to 2 and 3.5 round up to 4. Okay, let's do that. First of all, let's delete the previous rollout. Okay. First of all, let's change the value from _v2 to _v1. In this time, I'm going to use 2 steps. The first step will be 30, and the next step will be a pause with no duration. So if we update this rollout, we will have 2 pods for the new revision and 4 pods for the old version. The next step is a pause. We have to promote the rollout, and after that, all the traffic should be sent to the new version. Let's do that. I type kubectl apply-f example2.yaml. Very good. And example2-ingress. This is the new rollout. We have 2 steps only. Set weight equals 30% and a pause with no duration. If I update my rollout, for example, let's replace the _v1 to _v2. I type kubectl apply-f example2.yaml. As you can see here, we have 2 pods in revision 2 because 30% of 5 replicas is 2 pods. And we have 4 pods in revision 1, as I said here, because 70% of 5 replicas is 3.5 and rounds up to 4. So we have 4 pods for the old version. So if I type kubectl get ReplicaSet, the new ReplicaSet has 2 pods and the old ReplicaSet has 4 pods. We are in the second step. We have to promote the rollout manually, and after that, all the other traffic will be sent to the new version. Very good. And as you can see here, 30% of the traffic is sent to version 2. I type kubectl argo-rollouts promote rollouts set weight. So all the traffic is sent to revision 2 and revision 1 has been scaled down. So if I refresh this page multiple times, there is nothing about version 2 because all the traffic is sent to this version. Okay, it was about SetWeight&Pause. Very good. In this time, I'm going to use nginx-ingress-controller for Canary Strategy. But what is the scenario? In this scenario, I'm going to create multiple objects. The first object is a rollout. And then I'm going to create two different services. And the last object is ingress. We have a rollout that has a label called app rollouts traffic management. Rollouts. This is the label of this rollout. And then I'm going to create two different services. The name of the first service is Canary service. And the name of the second service is stable service. Both of these two services point to the same replica set of this rollout. Let's imagine that we are in revision 1 and we have one replica set only. In this time, both of them point to the same replica set. The selector of these two services is app equals rollouts-traffic management. Very good. So both of them point to the same replica set, to the first version of the application. If we switch to the new version of the application, for example, I change the image name or I change the environment variable or anything else under spec.template, Argo-rollouts controller will create a new replica set for the new version of the application. In this situation, Argo-rollouts controller will modify the selector of these two services and adds another selector to them. The key is PauseTemplate hash, and the value is the unique hash ID of the replica set. For the Canary service, the value is the unique hash ID of the new replica set. For example, 4567B. Argo-rollouts controller do the same for a stable service, but in this time, the stable service points to the old replica set. 1234A, for example. In this situation, Canary service points to revision 2 and points to new replica set. And a stable service points to version 1 and points to the old and stable replica set. This selector has been added by Argo-rollouts controller. But at the beginning, in revision 1, both of them point to the same replica set. We have another object called ingress. I'm going to create an ingress, and the backend service of this ingress is a stable service. So this ingress points to a stable service. Let's do this scenario. We have two different files for this example. Rollouts traffic management.yaml and rollouts traffic management-ingress.yaml. In rollouts traffic management.yaml, at the end of this file, we have two different services, Canary service and a stable service. Both of them point to this rollout, because the selector of these two services is app equals rollouts traffic management. So if we are in revision 1, both of them point to the same replica set, point to the same revision. Okay, let's move on to rollout. The kind is rollout, and the name of this rollout is rollouts traffic management. The number of replicas is 5. I've commented out these two lines, but I'm going to explain both of them, so don't worry about that. We have two fields here, Canary service and a stable service. This is the name of the service related to Canary. Canary service. This name and the name of this service must be the same. And a stable service. This is the name of the stable service. And this name must be the same. This is the name of the stable service. As I said earlier, I'm going to use nginx-ingress-controller in this example. Because of that, we have a block called traffic routing and another block called nginx. And this is the name of the ingress that I'm going to create. Rollouts traffic management. A stable ingress equals rollouts traffic management. We have another file here called rollouts traffic management ingress. And as you can see, this is the name of the ingress. This name, I mean the name of the ingress and this field must be the same. This is so important. In this example, I'm going to use two different steps, SetWeight&Pause. I'm going to send 20% of traffic to the Canary version and then pause the update process. And I need to promote and I need to unpause the rollout manually in this example. The label is rollouts traffic management. As you can see here, the name of the image is rollouts traffic management. The image is Canary, and this is the environment variable of this container. And these are two different services that I explained. And this is the ingress that I'm going to create. As you can see, the backend service of this ingress is a stable service. And this is the domain name that I'm going to use. This domain name exists and is available in my etc host. Okay. First of all, I copy the content here and let's create a new file called example3.yaml. Very good. And let's create another file called example3-ingress.yaml. So I copy this and paste it here. Okay. When I type HTTP equals this, there is no ingress right now. Okay, there's no problem. let's apply these two files. kubectl apply-f example3.yaml. Three different resources have been created. A rollout and two different services, Canary service and a stable service. And then kubectl apply-f example3-ingress.yaml. Okay, I have created this ingress already. Let's delete it. And then let's apply it again. Okay. In this time, if I refresh this page, you can see that we are in revision 1. And this is the rollout that we are using in this example. Okay. I want to show you something. As you know, we created an ingress called rollouts traffic management. This is a user-managed ingress. It means that we created this ingress for a stable service. But if I type kubectl get ingress, you can see that we have a new ingress. Surprising. What is that? What is this? This new ingress has been created by Argo-rollouts controller. If I type kubectl get ingress -o yaml, you can see that the backend service of this ingress that created by Argo-rollouts controller is Canary service. So this new ingress points to Canary service. In this ingress, we have two important annotations. Canary equals true, so this ingress acts as an alternative ingress to send the Canary traffic to this service. And we have Canary weight, the percentage of traffic that should be routed to the backend service. In this example, the Canary weight is 0. It means that all the traffic is sent to a stable service. Very good. Let's switch to the new version. I'm going to modify the value from _v1 to _v2.html. And I apply it. Very good. So, this is the number of replicas in revision 2, and it's 1. Because 20% of traffic is sent to revision 2. Because we have two steps. The first step is SetWeight equals 20%. So we are in step 2 and pause. We have to unpause the rollout manually. So if I refresh this page, only 20% of traffic is sent to version 2. If I promote this rollout, you can see that the revision 2 has 5 pods. But what about revision 1? Revision 1 is not scaled down, and it will scale down in 10 seconds. Okay? This is the default behavior of Canary Strategy when we are using a traffic manager. When using traffic routing such as nginx, by default, the stable replica set is left scaled to 100% during the update. This has the advantage that if an abort occurs, traffic can be immediately shifted back to the stable replica set without delay. However, it has disadvantage that during the update, there will eventually exist double the number of replica pods running. Okay, this is the default behavior, but it's possible to dynamically reduce the scale of the stable replica set during an update such that it scales down as the traffic weight increases to the canary. But how can we do that? If I refresh this page, we are in revision 2, and now there is no replicas in revision 1. Revision 1 will be scaled, the old revision will be scaled down in 30 seconds. This is the default behavior of the Canary strategy when we are using a traffic manager. But I'm going to change this default behavior. The desired state is scaling down of the previous revision dynamically. Because of that, we have a field here called dynamic stable scale. This is false by true, but we can change this behavior. Okay, so now I'm using dynamic stable scale equals true. It means that the previous revision will be scaled down dynamically. So I'm changing the default behavior of Canary strategy when we are using the traffic management. Okay. To prove it, I'm going to change this value to switch to a new version, for example, and then apply it. We are in revision 3, and let's see it. One of replicas of revision 2 is terminating dynamically. One pod is in revision 3 and 4 pods is in revision 2. And one pod of revision 2 is terminating dynamically because this field, dynamic stable scale equals true. So if I promote this rollout, the previous version will be scaled down dynamically without any delay, without any duration, such as 30 seconds or anything else. This is revision 3, and revision 2 is terminating dynamically with dynamic stable scale equals true. So we are changing the default behavior of Canary strategy when we are using traffic management. Okay. There is another option here called abort scale down delay seconds. If dynamic stable scale is set and the rollout is aborted, the Canary replica set will dynamically scale down as traffic shifts back to a stable. For example, you switch your rollout to a new version of the application, and then you decide to abort the rollout. In this situation, the new revision will be aborted in 20 seconds. So you can use this option if you want. Okay. In these two examples, in this example that we used two different steps, set wait and pause. It means that 20% of 5 is 1. One pod will be created for the new version of the application, and then we have a pause, and if we unpause the rollout, all other traffic should be sent to the Canary version or to a stable version. But there is another feature and option here. First of all, I'm going to comment these two steps. In this time, I'm going to use set canary scale with set weight together. I'm going to combine these two features together. What it means? This is the percentage, or this is the number of replicas of the Canary version. This weight means percentage. So 40 is a percentage. If you want to use a number, you can use replicas instead of weight. For example, 2. Weight 40 means 40%, and replicas to it means 2 replicas. You can use one of them. What it means? For example, you switch to the new version of the application. In this situation, Argo-rollouts controller will create a new replica set for the new version of the application. With 40% of 5 replicas means 2 replicas. So we will have 2 replicas of Canary version. And 40% of traffic should be sent to these 2 replicas. Okay? For example, I change 40 to 60. 60% of 5 is 3. So Argo-rollouts controller will create a new replica set for the new version of the application with 3 pods, because 60% of 5 is 3. So we will have 3 pods for the Canary version. And 40% of the traffic should be sent to these 3 pods, to these 3 replicas. So in this example, I'm going to combine these 2 fields together, set canary scale and set weight. Let's imagine that we have 10 replicas, and I set this weight to, for example, 10, and set weight to 90. If we have a rollout with 10 replicas, Set canary scale with weight of 10 means 1 pod. And it means that 90% of traffic will be sent to 1 pod only. So it's so important to set the correct numbers here, because we are combining these two different fields here. So in this situation, I'm going to create 2 pods of 5 replicas. Because of that, I set 40% of 5 replicas. It means 2 pods. And I'm going to send 40% of traffic to these 2 pods. So I set it to 40. And then we have a pod with no duration. And if I unpause the rollout, all other traffic will be sent to the Canary version that will be a stable version. Okay. First of all, let's delete the previous example. Very good. Okay. I'm going for the new rollout here. Okay. We are in revision 1 with 5 replicas. The canary scale is weight equals 40. 40% of 5 is 2 pods. So if we switch to revision 2, 2 pods will be created for revision 2. And 40% of traffic should be sent to these 2 pods. And then we have a pause. Let's do that. If we modify the value from app-value, app-v1 to app-v2, I apply it. Okay. 2 pods from revision 2 are terminating because of dynamic stable scale equals true. And we have 2 pods and we have 2 replicas of revision 2. And 40% of traffic is sent to these 2 pods. So if I refresh this page, 40% of traffic is sent to version 2. Okay? And we are in pause step, and I need to unpause the rollout. The revision 1 is terminating, and we are in revision 2 and a stable version, and everything is good. Okay, let's do another example. First of all, I want to delete the previous rollout. Okay. app-v1.html. In this time, I'm going to use replicas instead of weight. And I'm going to set a number like 3 for that. So if we switch to the new version, Argo-rollouts controller will create a new replica set with 3 replicas. And I'm going to send 30% of traffic to these 3 pods, 3 replicas. And all other traffic, I mean 70% of traffic, will be sent to a stable version. Okay, let's apply this file. Very good. I'm going to wait for the new rollout. Okay, we are in revision 1 with 5 replicas and canary scale. In this time, I'm using replicas instead of weight. And set weight is 30%. It means that the new replica set will have and will contain 3 replicas, and 30% of traffic should be sent to these 3 replicas. If I type kubectl get ingress, this is the ingress that Argo-rollouts controller created. As you can see, the canary weight is now 0. Let's switch the rollout to the new version. So I'm going to modify the value from f-v1 to f-v2 and apply this file. 3 replicas created for revision 2 because of this canary scale. The canary scale is 3 replicas. So we have 3 replicas here, and 30% of traffic is sent to this revision. So if I refresh this page, as you can see here, 30% of traffic is sent to version 2. And if I get this ingress one more time, you can see that the canary weight has been changed from 0 to 30. It means that 30% of traffic will be sent to this service, canary service. As I said earlier, if I type kubectl get svc, we have 2 different services. kubectl get svc canary service -o. Yeah. Argo-rollouts controller is responsible to add a new selector for this service, rollouts path-template hash. And this is the unique hash of the new replica set, of the canary replica set. This is the canary replica set. Okay? But what about a stable service? This is the hash of the old and the stable replica set. So a stable service points to a stable replica set. And the ingress, the canary weight of the ingress of canary is 30. Canary weight is 30. It means that 30% of traffic will be sent to these 3 pods. Okay, let's promote the rollout. And in this situation, revision 1 is terminating, and we have 5 pods and 5 replicas in revision 2. And revision 2 is now a stable revision, not a canary revision. Because of that, when I type kubectl get ingress, the canary weight is 0 because we are in a stable revision and there is no canary revision here. Because of that, we are in version 2 and there is nothing about version 1. And also get SVC and stable service and Canary service, both of them point to the same replica set because we have no Canary revision. Okay, it was about Canary strategy and using nginx-ingress-controller as a traffic manager and as a traffic router. That's enough for this session. Have a good day and see you soon.